Hello guys, my name is Dylan, my YouTube channel is Jared Jabels, and today we are going to be doing inverse function. So topic 1 is going to be our review. So maps and functions can be represented by a graph. So let's say we have our graph where it goes down to the right and then it curves. And so this is 1, 2, 3. This one goes like there. 2, 3. It's not the best, but it's gonna work. And so X is the input, and then the Y-axis is the output. So we have a test that can decide if something is a function, and it's called the vertical line test. So if you take like a line, so I'm going to use a ruler, and put it anywhere on the graph that's on the curve, and it touches only once, then it succeeds the vertical line test. But if it touches more than once, it does not, meaning that it is not a function. So this, for example, is not a vertical line, is not a function, because if I place my ruler right here, it touches here and here on the curve. So that's going to be topic 1. And so we can move on to topic 2, which is going to be example of an inverse function. So we can draw our little circle like this, like so. And so we can split it into 4 parts. So we go down the middle and then across. And so we can draw a triangle. That's theta, and that's the sine of theta. So theta is the input, and the sine of theta is the output. So what we can do is we can say that the y, so we can say y equals the sine of theta. So now, and then the sine, or the inverse sine of y equals theta. And so here we can like draw a bullet point. And so f of x equals 2x plus 1. Inverse f of x equals x minus 1 over 2. So if we have here f of 3, where 3 is equal to x, what do we get? Let's see, so 3 times 2 equals 6, plus 1 equals 7. Now over here, if we have f of 7, which is the inverse of this, let's see, so 7 minus 1 equals 6. 6 divided by 2 equals 3. So you get the inverse of what it is. So, for example, in real life, we can say if you open a door, the inverse is closing a door. But if you do the inverse of an inverse, for example, if you take 2 steps forward, and then you take 2 steps back, and then you do the inverse of that inverse, so just take 2 steps forward, then you're not going to go anywhere. You're going to end up where you started. So, that we can do more examples, such as f of 4 equals 9, and f of 9 equals 4. So that is it for topic 2. And so what we can do is we can draw a couple graphs that are part of topic 2 and 3. One of them is the one that we drew earlier, where it's at the beginning, where it's and then the other is for the horizontal line test. So it's just one, and then it kind of does like a wave. And so this one is a special function because it is also 1-to-1. Because 1-to-1 test is a horizontal line, so I can place a horizontal line and it only hits once, which is true. Now here though, it is a function, yes, because I can place it anywhere and it only hits once, but it is not a horizontal line. It is not a 1-to-1. Now, what would be one that is both, that will succeed the 1-to-1 test and an onto test, where does it exceed all the 1-to-1? So basically you can place it anywhere. And so that is, we can do something that looks like this. And it's this weird S shape where it's comes up and comes out, because it succeeds all of our tests. So that is it for topic 3, and we can move on to topic 4, which is how to find the inverse function. So here we have, for example, f of x equals 2x plus 1. So what we can do is we can inverse it, so instead of x, it's y equals 2x plus 1, and then x equals 2x plus 1, because we're switching them, and then y equals y minus 1 equals 2. And so this leads to x, because we change it, minus 1 over 2 equals y. And so we can switch this around, giving us y equals x minus 1 over 2, which gives us in the very end f of negative 1, or the inverse of x, the inverse of x, fx, equals x minus 1 over 2, which is what we started with. supposed to be -1. So thank you guys for watching. I hope you enjoyed, and I'll see you next time. Bye.